Welcome to 7.4 Part 2. So, looking at the back page of your notes sheet, we're going to now be finding more inverses and talking about something called the horizontal line test. So actually, we're going to be doing the same thing we did for example 1. The only reason it's in a different section is now the functions we're given are things like x squared, x to the fifth, stuff like that. So it's a little bit different than what we did before. And also, they're going to give it to you in official function notation with the f of x. But same thing we did before, where step 1, you're going to switch x and y. Step 2, we're going to solve for y. And now, the reason I wanted to make this in a special area is... Whoa, that is my dog, if you can hear that. My dog hates cats. If she sees one outside, it's just bark, 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 bark for a really long time. Anyways, okay, so what I was saying before was f of x is y. So if it might help your brain if before you do anything, just remember f of x is the same thing as y. So I have not yet done step 1 yet. All I've done is told you that f of x is y. So I haven't switched them yet. Alright, now I'm going to do step 1 and switch them. So step 1, switch x and y. Step 2, solve for y. To get rid of a square, we square root, and when I square root something, I put that plus or minus in front. So the inverse of x squared is plus or minus square root of x, and now that we're doing official function notation, we're going to do our inverse in official function notation. So I would say f inverse is equal to plus or minus the square root of x. There you go. Alright, so for each of these, remember, f of x is really y, so don't let that throw you off. Alright, part B. So y equals x to the fifth. Step 1, switch x and y. Step 2, solve for y. To get rid of a fifth power, I take the fifth root. When you take an odd root, you do not need the plus or minus. When you take an even root, you do. So this one is just the fifth root of x. And so in official function notation, my inverse is the fifth root of x. So now let me say something really quick. The reason you needed two answers if it's an even root is because, let's say that I wanted my answer to be 4 or something. This is just a side note. There are two things that I could plug in to make it 4 if it's an even power. So there's going to be two answers in your when you take a square root. But if I had an odd power, there's only one way I can get something, because if I change the positive or negative, it's a different number, so it's not the same. So when you have an odd root, you don't put the plus or minus there. When you have an even root, you do. It does get slightly harder, so let's look at example C. So again, remember, f of x is just y. Step 1, switch y and x. Step 2, solve for y. So we're going to use normal equation solving things, but there's going to be some stuff with order of operations you might kind of not be sure about, so pay close attention. If this was a normal y, I would normally add 2 to both sides first. That's what I do here. So add or subtract first if you can. We're basically doing the order of operations backwards whenever you solve an equation. And then I want to tell you that before you take a cube root, we have to get everything over here. So that's why I wanted to add 2 first. So I wanted to get rid of the 2, and I also want to get rid of the 1/2, and then when I have y cubed by itself at the very end, that's when you take your root. So don't take your root until the very end. To get rid of a 1/2, let's multiply by the reciprocal. So I'm going to multiply both sides by 2 over 1. And so when I do that, I got 2x plus 4 on the left side, and now y cubed is by itself. Alright. So I'm going to just say get the power by itself before taking a root. And I hope you're looking at this and in your mind you're thinking, oh, it's a y cubed, so to get rid of a cube, I'm going to cube root it. And it's an odd root I just did, so I don't have to put the plus or minus in front. And in official function notation, the cubed root of 2x plus 4 equals f inverse of x. And notice how I had to cube root both sides, and 2x plus 4 are both underneath the root. That's really important. If you don't show both of them under the root, you lose points for that. And they're both under the root because they were both on that side that I was cube rooting at that time. Part D. Why don't you pause the video and try it on your own? Alright, if you are unpausing, you should have an answer of plus or minus the square root of 1/2 x or x over 2 plus 2. So let me, if you got it correct, move on. If you didn't, let me show you how I got that. Switch my x and y. And again, before I root it, I want to get my power by itself. So I'm going to add 4 to both sides to start off with. I'm going to divide by 2. And when you multiply or divide, do it to everything. And I also could have said multiply by 1/2. Either one would have been correct. And now to get rid of a square, I'm going to square root it. And because it's an even root I'm doing, I put the plus or minus in front. And that's how I got this for my answer. Last but not least, for this section of notes, we're going to talk about how to figure out if something's a function just by looking at the graph. So we talked about determining if two things are inverses of each other. But this is different because now I want to know, like, well, you can find an inverse that is not a function. So we want to know, let's say I found an inverse. Is my inverse a function or not? And sometimes the inverse is not a function like I just said. I'll just write that down in case you want to jot it down as well. Your choice though. Sometimes the inverse is not a function. So in order to figure out if it is or not, we have a handy dandy test that we're going to do, and review from GO2. Do you remember to figure out if a normal graph is a function or not, we did the vertical line test? And I'll give you an example of that with example 4a. But we use a vertical line test to determine if something is a function. And that was performed on the original graph. Okay, so if I was going to do review vertical line test, I would have taken my picture, I would have tried to draw a vertical line, and if it only touches my graph in one spot, then yes, it's a function. And so if I look at part B, I draw a vertical line, only hits it in one spot, yes, the original is a function. So everything I just did, that was review. Now I want to teach you the new thing. So this is called the horizontal line test. And the horizontal line test, we actually do it on the original graph as well. So we perform the horizontal line graph test on the original graph, and it tells us if the inverse is a function or not. So here's what I mean. Like, I have my original graph. I don't know what the inverse looks like. I do a horizontal line test, and that actually will tell me if it only hits in one spot, yes, the inverse is also a function. For example 1a. So this is the part that students think is kind of weird. You do the horizontal line test also on the original graph. So vertical line test on the original graph, and the horizontal line test on the original graph. You don't actually have to graph the inverse to figure this out. Alright, so let's look at example B again. To figure out if the inverse is a function or not, I do my horizontal line test. If it touches twice, then it's a no. So this time, no, the inverse is not a function. Let's do two more. And now here for these, we're going to have to graph them on our own. We haven't really done any reviews of graphs yet, so I hope you remember how to do this. But if you get stuck and you're not sure what to do, you could go in your graphing calculator and type it under y equals and try to look at the picture. For this first one, I can see that it's a linear something or other because I just see a regular x. So in my mind, I'm thinking, okay, y-intercept and slope. So I'm going to graph my original. So I'm going to start with the y-intercept down at -6, and then I'm going to use my slope to find my next point. The slope is 3/4, so up 1, 2, 3 over 1, 2, 3, 4, up 1, 2, 3 over 1, 2, 3, 4. That's enough for us to be able to use our tests. So first of all, Is the inverse, or is the original a function? Yes. Original is a function. Next question, is the inverse a function? Only hits it once, so yes, inverse is a function. Alright, the graph y equals x squared minus 6. Again, you can use y equals on your graphing calculator, and then here's what I would do if I were you. Go under y equals, type this in, and then look at your table of values. So you're going to hit second and then the graph key, and that gets you to the table, and that'll give you the exact x, y, so that you can make exact points on your graph. When you're doing this on your homework, you can kind of just try to do some exact points, but it's not going to look super great. That's okay with me. We don't have to use graph paper for this. So if I go through and do this, I end up with something that looks like this. So that's approximately what it looks like. And you can see this is very similar to B, so you probably can just look at it and know the answers. But is the original a function? Yes. Original is a function. Is the inverse a function? No. The inverse is not a function. It hits it twice. Alright, that is the end of 7.4. Yay!